是有啊。
University Calculus, lesson 16, supplementary question. This is about inverse function. So let's have an example of an inverse function. This is a given function. What is the inverse function? The inverse function is change x to y and change y to x. So the inverse function is this. So this is given, and this is the inverse. This given function is a parabola. This is a given function. It's a parabola. The vertex is at 0, 4. What is the inverse function? It's this. So the inverse function is change y to x, x to y, and it looks like that. How do we draw the inverse function if the given function is given? You draw a line. You draw a line y equals x. This is a straight line, and this angle is 45 degrees. How do you get this? How do you get this from this? You do a reflection in this line. If you do a reflection in this line, this point goes to here. 4. And the graph goes to here. You reflect, and it is this function. So, how do you get the inverse function? You do a reflection. Do a reflection in this line, y equals x, and the original function goes to this new graph, which is our inverse. Now, the supplementary question is a suggestion that you can get the inverse doing in another way. Okay. So what is another way? Let's erase this. This another way says the first step is to do a reflection of this. Reflection in the x-axis. Okay. So let's have this. I think this pen is not writing well. So this is the given function, given graph. The first reflection in x. So your reflection in x. That's a reflection. Let's erase this. After that, you do a rotation counterclockwise by 90 degrees. So you rotate this by 90 degrees. So if you rotate this counterclockwise 90 degrees, this becomes this. So you rotate it 90 degrees. You get this. And this is exactly our inverse function. So the second step, rotate 90 degrees counterclockwise. So this is the question, the supplementary question. This question suggests that you can get the same inverse graph by doing two steps, reflection in x-axis and rotate 90 degrees counterclockwise. And the question is asking us to prove it. Prove this. To prove it. So how do we do that? Now we use this special example to show that this is true. If you do step 1, step 2, you indeed get the inverse graph. But the proof means we want to prove it in the general way. So how do we prove it generally? So let the given function be y equals f of x. That's a general way of writing the function. So step 1, you do a reflection in x-axis, which means this is step 1. You do a reflection in x-axis. Step 2, you do a rotation 90 degrees counterclockwise. Then, mathematically, how do we write this? Then we need to consider something. Suppose I have a point here, and this point is 2, 1. I have a point, x coordinate is 2, y coordinate is 1. And I want to rotate this point 90 degrees counterclockwise. So this point goes to here now. Somewhere here. Right? So from here to here is 90 degrees, which means this is 90 degrees. And let's draw a rectangle. Let's draw a triangle. So this side is 2 now. See? And this side is 1. Then this triangle turns 90 degrees counterclockwise. Therefore, this triangle, they are the same triangle. They are congruent. And this 2 means this is 2, right? You rotate So this 2 is this 2. This 1 becomes this side 1. So what is the x coordinate, y coordinate, the new x coordinate, y coordinate? The new x coordinate is this, which is -1. What is the new y coordinate? Which is 2. So you see, this 2 becomes here, goes to here. And this 1 goes to here with a negative sign. So what is the rule? 90-degree counterclockwise. What is the rule? The rule is the original xy becomes x becomes y. The y coordinate becomes -x. This is a rule for rotating 90-degree counterclockwise. So we apply this mathematical result to this. The result of step 1 is this. Then we apply this. Y here becomes -x. So y becomes -x. X becomes what? X becomes y. So cancel the negative sign. Cancel the negative sign. So what do we have now? X equals negative cancel. X equals f of y. Look, this is the given function. This is our result after the 2 steps. What does this tell us? I change y to x. I change x to y. Therefore, this is exactly the inverse function. So this is the inverse function. So we proved all supplementary questions. Proved, right? So we proved. Today's lesson is very short, and I hope you follow this. So I'll see you next time. Goodbye.